Hello, and welcome to this video. So in this video, we will solve 49th set of problems, that is question number 481 to 490. And the link to download the PDF will be in the description. And I'll also show at the end that how you can download the PDF from the website, plus other PDF on trigonometry. So I'll say what I always say in my videos is that when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So question 481 says that if the cubic equation f of x is equal to 0 has three real roots alpha, beta, gamma such that alpha less than beta less than gamma, show that the equation f of x plus 2f dash x plus f double dash, not dash, f prime x and f double prime x is equal to 0 has a root between alpha and gamma. So clearly this question requires knowledge of calculus because we are going to calculate the derivatives and all. If you don't know calculus, come back to this question later. Okay. So we let a function g of x is equal to e to the power x f of x. Then g double prime x, that is the second derivative, will be equal to ex into f of x plus 2f dash x plus f, not dash, prime, f prime x plus f double prime x. So roots of the equation will be same as that of g double prime x is equal to 0 because e to the power x is non-zero. Also, e to the power x is always greater than 0. Therefore, the roots of equation, that is of f of x and g of x, will be same. There is a backslash missing in this. Okay, this should be beta. So clearly, gx is equal to 0 will have alpha, beta, gamma as the roots, same as f of x. And g prime x will have a root a between alpha and beta and a root b between beta and gamma. And therefore, equation g double prime x will have one root between a and b, and which obviously lies between alpha and gamma. Question 482 says that find the values of a for which all the roots of the equation x to the power 4 minus 4x cubed plus minus 8x squared plus a is equal to 0 are real. So if you plot, this is what will be the plot of the function f of x will look like, where f of x is equal to x to the power 4 minus 4x cubed minus 8x squared. Now note that in this case, we have not taken a here, okay? So compute f dash x, we get three roots, two roots for f dash x, three roots, and those roots are minus 1, 0, and 4. So you look at these terms, okay? So at x is equal to minus 1, there'll be a tangent parallel to x-axis. At this point, there'll be a tangent parallel to x-axis, and this point, there'll be a tangent parallel to x-axis. Now, if you see this particular plot, this particular point is minus 1 and minus 3. Now, if you add a, the graph moves up. So if you add a, this graph will move up, and then there will no longer be four roots. That is, these roots will vanish. That is, the roots at minus 1 and 0 will vanish, and we will have one more root here, okay, which will touch it. But if you increase further more than 3, then this root will also vanish. So what you will have is only one root, that is for, there will be two roots actually. One when this curve will come down, and one once when this curve will go up. So for the curve left to this position, there will be no root. For the right side, there will be two roots, and two roots will go to complex plane. Okay, because when you plot a function and you can't see a root on the that is if you see that curve is not cutting x-axis, then the plot has what you call complex root. I'll give you an example. Suppose we have a quadratic equation whose two roots are 1 plus I and 1 minus I. Now sum of roots would be 2. Okay. And if you multiply, then the product of roots will be 2. So if you look at an equation x squared plus 2x plus 2, then you will see that parabola never cuts the x-axis. Okay. That means both the roots are in complex plane. So similarly here, this is a fourth degree equation, and if we move this plot up by more than 3, that is a is more than 3, then we will have only two roots and 2 will go to the complex plane. So it is clear that for 4 real roots, a should be between 0 and 3. Alright? Okay. Now again you can ask the question, what if a is negative? So if a is negative, this will come down, and then this tangent, this point will move further down, and then again you will have two roots, that is at one of this one and one of this one. So again it should be greater than 0. So that's what you can get from the figure. So it was an advanced question, but yeah, I hope that you understand that. Now we come to question 483. It says that if the equation x squared minus bx plus c is equal to 0 has two distinct real roots between 1 and 2, where a, b, c are in the set of natural numbers, so that a greater than equal to 5 and b greater than equal to 11. So again, very interesting question. So we let alpha beta to be the two roots. We have from beta relationship, alpha plus beta is equal to minus b by a, alpha beta is equal to c by a. Now we know that arithmetic mean is greater than geometric mean. So what is given here is that the real roots are between 1 and 2. So that means alpha 1 minus alpha, beta 1 minus beta will be between 0 and 1. Okay. All right. So let's see whether they will be between 0 and 1 or not. Okay. I don't think it is correct statement, because if alpha is 2, for example, between 1 and 2, so if it is 1.9, then minus 0.9 will not be greater than 0. So take it with a piece of grain of salt. This is not correct. Okay. In any case, we consider alpha and 1 minus alpha. So assume that it is positive. 1 minus alpha is positive for now. Okay. That is alpha is less than 1 but greater than 0. Okay. So if you take AMGM inequality, you will see that alpha into 1 minus alpha is less than or equal to 1 by 4. And then beta into 1 minus beta will be also 1 by 4. So you multiply those, you get alpha beta into 1 minus alpha into 1 minus beta less than 1 by 16. And from here, then you apply the Beta's rule, you get 16c a minus b plus c less than a square. Okay. So the minimum of this c into a minus b plus c is 1. So a square is greater than 16. That is, a minimum is 5. And similarly, your b minimum is 11. Now we look at this again. Okay. The required condition for this GM is that alpha into 1 minus alpha should be positive, and so beta into 1 minus beta should also be positive. Okay, so we have got a bit of work here to do. All right, so if you square this, if it is a negative, it will become an imaginary quantity. Okay, so I'm not sure that this is correct assumption here. All right, because if alpha is greater than 1, okay, now, okay, let me think a bit. As two distinct real roots between 1 and 2, okay, between 1 and 2. Now we have to find A and C. So let me think for a few seconds. All right. Now for this range, okay, for what it means is it is not saying that alpha, beta are between 1 and 2. So what this means is alpha is between 0 and 1. Okay. So if alpha is between 0 and 1, then alpha and 1 minus alpha are both positive. Alright. So that is true. Now what if alpha is between 1 and 2? Okay. If alpha is between 1 and 2, then alpha will be positive and 1 minus alpha will be negative. So it will not be the case for that. Okay. It is not always true. Two distinct real roots between 1 and 2. So no. Now what can happen is alpha can become greater than 2. 1 minus alpha less than 1. So alpha goes that side. Alpha is greater than 2. Alright. But at the same time, if you see alpha is less than 1, so no, the common does not occur there. Okay, if you discard the left side, if you look only at the right side, if alpha is less than 1, then 1 minus alpha is greater than 0. Okay, so it is cumulative. So I don't think this is the 100% correct answer of what I have presented. I will see this and I will resolve this problem again, okay? Or maybe it is some mistake in my understanding. All right. So now we move on to question 484. Now I have two problems to explain here. One is 483 and another problem I remember is 444, which I have not explained properly. So I'll probably at the end, once we finish the quadratic equations, I will do this again, okay? Maybe my understanding is not correct about this question. So we come to question 484. Show that the equation x minus 1 to the power 5 plus x plus 2 to the power 7 plus 7x minus 5 to the power 9 is equal to 10 has exactly one real root. So the given equation is x minus 1 to the power 5, x plus 2 to the power 7, and 7x minus 5 to the power 9 minus 10. Then if you look at this equation, then f of minus infinity is minus infinity. The reason is that this x to the power 9, when you evaluate this, will dominate the entire expression. And similarly, f of infinity will be infinity. Now, if you differentiate it, you will see it is 5 into x minus 1 to the power 4, 7 into x plus 2 to the power 6. This should be power. And then here we have 63, 7x minus 5 to the power 8. Now all these terms have even power, so they'll be always greater than 0, which means fx is always increasing and they cut the x-axis only once, so we will have only one root. Question 485 says that find the value of tan theta plus phi and cot theta plus phi, where tan theta and tan phi are respectively actual and extraneous root of the equation. The square root of 2x plus 6 minus square root of x plus 2 is equal to 3. So we square this given equation, we get 2x plus 6 plus x plus 2 minus 2 into square root of 2 into x plus 3 into x plus 2 is equal to 9. So you bring all this to one side along with 9 and then you square again. And finally you will arrive at solving that x is equal to 47 and minus 1. So on putting this in the original equation, we see that 47 is the actual root and x is equal to minus 1 is extraneous root. So tan theta is equal to 47 and tan phi is equal to minus 1. Once we have tan theta and tan phi, it is trivial to calculate tan theta plus phi and cot theta minus 5. Now, if you have not yet studied trigonometry, forget about calculating this. Go ahead and learn trigonometry, and then you will know how we compute these values. So the calculation is not shown here. Okay. Question 486 says that solve mod of x plus 1 minus mod of x plus 3 into mod of x minus 1 minus 2 into mod x minus 2 is equal to x plus 2. So we take the first case, that is x less than minus 1. So the equation will become, all the mods will become negative here if x is less than minus 1. Okay. Hang on, if x is less than minus 1, all right, so this will be negative. All right, so this becomes negative. x will be x should also be negative, right? So negative negative plus becomes positive, and this x minus 1 should be negative, so this should remain negative, and this becomes minus 3x plus 3, and then we have 2x minus 4 is equal to x plus 2. So finally we get x is equal to minus 2, and you repeat this when x is minus 1 greater than minus 1 and less than 0. First term will be positive, rest will be negative, and then we will have x is equal to x plus 2, which is not possible. Similarly, between 0 and 1, what will happen is that first two terms will be positive, third term will be negative, you solve, and finally you do it for, sorry, not finally, in case 4, you do it for between 1 and 2. So first three terms will be positive, and this will be negative. And again, you solve, you get x is equal to 2, but our assumption is that x is less than 2, so it is not possible. And when x is greater than 2, we arrive at x plus 2 is equal to x plus 2, because in this case, all mods will be positive, and it is always true, means for all values greater than 2, it will be correct. So the entire solution set is minus 2, and x is equal to minus 2, and x is greater than equal to 2. Now we move on to question 487. We have to solve 2 to the power mod x plus 1 minus 2 to the power x is equal to mod of 2x minus 1 plus 1. So we take the case when x is less than minus 1, so mod of x plus 1 will be negative, so the equation becomes 1 by 2 to the power x plus 1 minus 2 to the power x is equal to minus 2 to the power x plus 1 plus 1. So we get x is equal to minus 2. So here you might ask that, I have not explained this side, let me explain it. So our condition is x less than minus 1. So if x is less than minus 1, 2 to the power x will be less than 1. So this entire term will become negative. So that's why we have the negative sign. The second case, you take minus 1 less than x less than 0. So again, right hand side will become minus 1 by 2 to the power x plus 1, and left hand side will be 2 to the power x plus 1 minus 2x. So it's simple. So go ahead and read. It's a trivial problem, and I'll skip the reading for this. So we finally arrive at the solution, x is equal to minus 2 and x greater than equal to 0. Question 488 is similar. We have to solve x square minus 2x plus y is equal to 1 and x square plus mod y is equal to 1. So first case is that the key thing in these four equations from 486 to 489 is finding the ranges. Different cases is what we have to find. So the case 1 is when x is less than 0, y is less than 0. So why we want to take that? Okay, because we want to make everything negative. Okay, so if you look at this, then x square minus 2x will become positive and y will become negative. Mod y will become negative. So we get two solutions, x is equal to 1 minus root 5 by 2 and y is equal to 1 minus root 5 by 2, which are both less than 0. Now the second case could be x is less than 0, y is greater than 0. So you do the same thing, you arrive at x is equal to 0 and y is equal to 1. And third case could be x is between 0 and 2 and y is less than 0. So in this case, we arrive at x is equal to 1 and y is equal to 0. And the fourth case could be that x is between 0 and 2 and y is greater than 0. So in this case, x becomes 0 and 1 and y becomes 1 and 0. So 0 we have to discard because y is greater than 0. And then we have two more cases. So please go through it. And when you combine the solution, you have x is equal to 0, y is equal to 1, x is equal to y is equal to 1 minus root 5 by 2, x is equal to 1 and y is equal to 0. Now we come to question 489. We have to solve mod of x square plus 4x plus 3 plus 2x plus 5 is equal to 0. You see, it will have two roots, minus 1 and minus 3. So we will have three cases. When x is less than minus 3, the quadratic expression will be positive. So it will be x square plus 4x plus 3 plus 2x plus 5 is equal to 0, which gives us x is equal to minus 4 and minus 2, but x is equal to minus 2 is not possible because x is less than minus 3. And when x will be between the roots, the term inside mod will be negative. So when we solve this, we get x is equal to minus 1 plus minus square root of 3. But minus 1 plus root 3 is not possible because x is negative, and this is positive. And the third case will be when x will be greater than 1. So we'll have x squared plus 4x plus 3 plus 2x plus 5 is equal to 0. We will have x is equal to minus 4 and minus 2. Both are not possible. So we have two solutions, minus 4 from here and minus 1 minus root 3 from here. Now we come to question 490. Solve x squared plus 9x squared by x plus 3 whole square is equal to 27. So we have a given equation. We simplify, we get x to the power 4 plus 6x cubed minus 9x squared minus 162x minus 243 is equal to 0. And x is equal to, x is not equal to minus 3. Now assume that this fourth degree equation is product of two quadratic equations. Then we compare the coefficients. We get a plus c is equal to 6, b plus ad is equal to minus 9, ad plus bc is equal to minus 162, and bd is equal to minus 243. So we have four equations, four unknowns, and you solve those. You get a is equal to minus 3, b is equal to minus 9, c is equal to 9, d is equal to 27. And once you have ABCD, you substitute in these two quadratic equations and solve for roots, and you get these values. So with this, we come to the end of 49th set of problems. And I'm sorry that I could not explain question 483. Okay, my mind is not in the right place today. And I'm also apologizing for not fully explaining these simple problems between 487 to 489. These are very simple if you understand mod. So if you want more explanation of these questions, let me know in comments. 483 I will see. 444 and 483 I will explain. I will have to possibly work on both the problems and then I'll show them. So we will slot that for the end. Why we can slot that for the end is the reason that in the end we have only 5 questions in this 56 set, so we'll add them here. Okay, so it will become 6 questions. So with this, I will end the video, and I hope that you are enjoying the video and finding it useful. Yeah, so keep working, keep solving more and more problems, and I'll see you in the next video. Enjoy.